Okay. I just want to make sure I can actually control it.
Okay, welcome to this presentation. Our group chose the spring project for our presentation. Right here, we went on to QA1, and well, this was actually from Speedway Motors to select a spring for a 1942 Chevy Coupe. The idea is that on the website, you're offered plenty of different options on spring rate. So we wanted to choose a spring that was going to be comfortable for the riders.
The details and the material we chose for this particular project, the main material was chrome silicon. And then we had these sets of constant values that we were looking at. The spring length, shuttle height, installation length, and inside diameter, wire diameter, spring rate, and force. For the force, we were able to do a few iterations with that where at some point we did the calculations for it, and then at the other point where we were keeping it constant and see how it changes.
So for the MathCAD process, first things we thought was important is to calculate the appropriate wire diameter. For this one, the D assumed has to be close or equal to the D value that we got. Second one is to calculate the shot height, making sure that the spring doesn't go lower than the shot height. We set the clash allowance to 12%. And then after that, we calculate force variation, which means the alternating and the mean force using the maximum and minimum force on the spring. And then we calculated the strengths using the values we figured out or we found from the book. After that, we calculated the stress at different force levels. And then after that is to calculate safety factor and the forcing frequency.
For creating the FEA analysis, we were doing a couple of different designs for the spring to try to make it possible to apply the force properly and get the results we wanted. We ended up having to create a custom material for the spring as the material that the MathCAD analysis was done on was not available originally in SolidWorks, so we just added the details in ourselves. We had to make some changes based on the amount of force that was applied to it and then multiply it back to what it should be later on just to avoid a large load error while doing the FEA analysis. Unfortunately, after all of this was done and some changes were made to try to improve it, the results still didn't match the hand calculations, and we'll get a little bit more into that.
So when comparing our results of the MathCAD versus the FEA, our biggest percent difference came from the displacement. When we calculated it, it came out to 103.4 millimeters. However, when we ran the FEA, it was 68. So that gave us a large percentage difference of 41.3. When looking at the max stress and the stiffness, our numbers much more closely compared. So with the max stress, we had a calculated value of 760.3 megapascals versus the FEA's 758.7, giving us a percentage difference of 0.2. And then with our stiffness, we had a value calculated at 36.95 newtons per millimeters versus the FEA's 40.36, which gave us a little higher percentage difference of 8.3. With the displacement, our best hypothesis for why the difference was so large was because of in our FEA, our mesh maybe wasn't fine enough or not done at a better scale. However, there could be errors in the calculations as well.
So to summarize here, we're looking at the safety factors, fatigue safety factor. Fatigue safety factor is telling you if the spring is going to break or not. And since all of these are above 1.0, we can assume that these three springs that we calculated would all function properly and they would not break. You can see the stress safety factors are kind of interesting because when you go from 35 spring to a 52 spring, the value goes up and then it goes up again for 70. So that just shows the spring would perform better. On the far right, you see the forces also increase as the K value for the spring increases. Yeah, at the end of the day, it was left up to the end user to choose a spring. Since they're all safe and none of them would break, you have to decide if you want to have a spring in your car that's going to ride soft or a stiffer spring, which will provide more force down for traction. We did think that further testing would need to be done to verify our results, and also a large question mark in this project was the wire diameter. You see, we went from 11 to 12 to 13 millimeter. Those were all just guesses, and so that definitely contributed to our errors. But I think we made pretty good assumptions. And here's our references. We have Norton. There's the website from the spring. And also there's a reference in there that will reference back to the report. Thank you. Did anybody else have anything to share?
No, I believe that we are good. However, on the recommendations, just a little bit to talk about. The dependence on which one somebody would choose could depend on how they're using their vehicle. So, if you're going to be driving a lot more on bumpier roads or situations like that, or if you're just city driving, that could kind of be the difference between which one you would want to choose. Um, but yeah,
Thank you for your time.
thank you.